Hi, my name is Goodluck. Welcome to Radiant Minds Academy. In this video, we will discuss about the concept of change of base and how to use change of base to solve logarithmic problems. Because most times we can be confronted by bases that are not conducive to work with. Sometimes the basis can be in decimal, sometimes can even have a square root value, and with that, we can be able to use the concept of change of base to work with those bases and simplify the problem. Also, this method allows us to calculate logarithms with other bases, not only base 10 and our natural log, which is base E, but with other bases. And today, we will discuss about this change of base and use it to solve some problems. Now, for us to apply change of base, we must know that if we are given a logarithm that, let's say, log n to base b. To change this base, we will introduce a new base, and this can be expressed as log n to base c, where c is our new base, divided by log b to base c. This is the concept on how we change base in logarithm. So you see, we have a base which is already base b, but because this base is not convenient to work with, we are able to change it, and then we introduce a base which is what? Base c. And this base c will help us to be able to simplify a logarithm given to us. I believe you have gotten it, but to strengthen this understanding, let's solve some examples. Now we have two examples on the board, example 1 and example 2. Example 1 says, find the values of the following: log 16 to base root 2, and the second of number 1 is log 32 to base 0.25. Again, example 2 says, if log 2 is equal to x and log 3 is equal to y, find the value of log root of 1 divided by 72 to base 27 in terms of x and y. Now we will solve these two examples, and these examples will help us to understand and master the concept of change of base. Let's solve the examples. Now, number 1I says log 16 to base of root 2. Now you can see that our base is a radical and is not convenient to work with, so we can change the base. So this expression can become log of 16 root 2 will be equal to log of 16 to base 5 divided by log of root 2 to base 5. Now we have chosen a complete base for us, which is base 5, for us to be able to simplify the problem. So at this point, we can express 16 as the power of its base. So we have that log of 2 raised to power 4 of base 5 divided by log of 2 raised to power of 1 divided by 2 all to base 5. Now at this point, we know that from our index law, our logarithm becomes 4 log 2 to base 5 divided by 1 over 2 log 2 to base 5. Now, since we have log 2 to base 5 and log 2 to base 5 in both numerator and denominator, the both of them will cancel out. We will be left with 4 divided by 1 divided by 2. So therefore, our answer becomes 8. From here, we can see that log 16 to base of root 2 is equal to 8. Now you see we are able to solve this because we changed the base of our initial expression to a more convenient base that we can work with. Now let's take up number 1II question. Now the II said log 32 to base 0.25. Now let us put our base in fraction So here we have log of 32 base of 1 divided by 4. So now it's obvious that our base is a fraction, so we can able to change base so that we can be able to work on this expression. So we can have that log of 32 to base 1 divided by 4. If we choose the complement base, now we're choosing 2 as our base. This can be log of 32 to base 2 divided by log 1 over 4 to base 2. So from here, if we express 32 as the power of its base, we have log of 2 to the power of 5 to base 2 divided by log of 4 minus 1 to base 2. So from here, we can further express this expression as log of 2 to the power of 5 to base 2 divided by log of 2 to the power of negative 2 divided by base 2. Now we know that from our index law, we can have that this becomes 5 log of 2 to base 2 divided by minus 2 log of 2 to base 2. Now since log 2 to base 2 is equal to 1, that is logarithm to its base is equal to 1. So therefore, we'll be left with 5 divided by minus 2. That is our answer. So you see, number 1 I question we had with 2 as our base, and number 1 I question we have the decimal as our base. So we are able to simplify this by the concept and with the knowledge of change of base. It looks very simple. So I believe that these 2 examples must have strengthened your understanding. Now let's take number 2. So now let's solve number 2 question. They said if log 2 is equal to s and log 3 is equal to y, find the value of log root of 1 divided by 72 in base 27 in terms of x and y. Now how do we solve this? First, we don't have to panic. All we need to do is to take our instruction. They said that log 2 is equal to s and log 3 is equal to y. This means that we have to simplify this expression to a point where we have both log 2 and log 3. So first of all, we have to change our base. Now if you watch here, we have log 2. This also means that log 2 to base 10. So also it will be log 3 to base 10. I hope this has been clear. Okay, let's go. So from here, we choose 10 as our base since our conditions are all in base 10. So therefore, we have that log of root 1 divided by 72 to base 27 is equal to log root 1 divided by 72 base 10 divided by log of 27 to base 10. Now at this point, we will take up the root from 1 divided by 72 and we express 27 as the power of its base. So our expression becomes log of 1 divided by 72 all to the power of 1 divided by 2 in base 10 divided by log of 3 to the power of 3 in base 10. Now from here, we can apply our index law. So from our index law, this becomes 1 divided by 2 times log 1 divided by 72 all in base 10 divided by 3 log 3 in base 10. Now we will express 72 as a product of this factor. the expression becomes 1 divided by 2 log 1 divided by 8 times 9, or in base 10, divided by 3 log 3 in base 10. This can further be simplified as 1 divided by 2 log of 1 divided by 8 times 1 divided by 9, or in base 10, divided by 3 log 3 to base 10. Now, we can further write that this will be 1 divided by 2 log 8 raised to the power of negative 1 times 9 raised to the power of negative 1, or in base 10, divided by 3 log 3 in base 10. At this point, let's express 8 and 9 in the power of their base. So our expression becomes 1 divided by 2 log of 2 raised to the power 3 multiplied by the power of negative 1 times 3 raised to the power of 2 or raised to the power of negative 1 divided by 3 multiplied by log 3 to base 10. Now at this point, we can express our numerator further as 1 divided by 2 log 2 raised to the power negative 3 times 3 raised to the power negative 2, or in a bracket of base 10, divided by 3 times log 3 to base 10. At this point, we have to apply the addition law of logarithm. Our expression becomes 1 divided by 2 log 10. This will be 2 raised to the power negative 3 plus log to base 10 3 raised to the power negative 2, all divided by 3 log 3 base 10. So at this point here, we are going to apply our index law. If we apply that, we have 1 divided by 2 minus 3 log 2 to base 10 plus minus 2 multiplied by log 3 to base 10, all divided by 3 times log 3 to base 10. Now at this point, we have been able to simplify our expression. Since log 2 is equal to x and log 3 is equal to y, we substitute. So we have that this will be 1 divided by 2 minus 3 times x plus 2 times y, all divided by 3 times y. So we can simplify further, and our expression becomes minus 3x minus 2y divided by 6y. At this point, we are able to show in terms of x and y the value log root of 1 divided by 72 to base 27, and this is the answer. Please, if you know you found value in this video, don't forget to subscribe and like this video. Please, if you have any question on the steps we took you didn't understand, please drop a question at the comment section and I will reply you. And don't forget to share the video. See you in the next one. Thank you so much.